I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, November 10th. Tonight we'll be discussing jet stream level winds, surface level pressure, significant wave heights, and all the things that go into making surf in the North Pacific Ocean. And also we'll take a quick look at potential for precipitation in California. Let's get to work. Looking at significant wave heights in the North Pacific Ocean, we see the start of a gale producing 22-foot seas aimed at the U.S. West Coast. This one has a little bit of potential. And then there's also the start of something else pushing off Japan. Not looking like very much right now, but the future definitely holds promise for this. And then even more beyond that. So, an active pattern is setting up. As usual, we'll start off looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when they do form, help direct their track. We have a consolidated jet. This is looking good, with winds building to, what is that? About 160 knots, ridging over the dateline to the north, and then falling into a developing trough north of Hawaii. And it's a trough, that's what we're looking for. This sort of creates a counterclockwise flow aloft in the atmosphere and down at the ocean surface, and that is the hallmark of low pressure. That is winds rotating in a counterclockwise fashion. And low pressure, if it's deep enough, creates stronger winds. Winds generate seas. Seas generate swell. And swell, when it hits your beach, creates surf. All right, so we have a pretty decent setup right now in the Gulf of Alaska with a trough there. Put this into motion. See that trough kind of pinches off and lifts to the north on Monday. So support for gale development will probably end there. But look at this. The jet quite healthy with, 120 knot flow, consolidated the whole way across the Pacific, at least to a point a little bit northeast of Hawaii. And then we have this persistent ridge holding off of California, preventing moisture from working its way in there. But notice this. Look at this up here. Starting, when is that? About Monday night or so, Tuesday, another trough starts carving out, again being fed by about 160 knot winds and building. This is, look at this, it's kind of fully encased trough here, pushing hard east into Tuesday night and into Wednesday, and then it too starts fading. Notice the jet split, but a portion of the jet almost looks like it's going to work its way into California, and yet another trough develops as we get into Thursday. This one again being fed by 170 knot winds, and that too pushing through the Gulf, looking pretty solid into Friday. And then it has this dead spot here between, at the apex of the trough. So that doesn't help a whole lot. Then things get kind of fragmented as we get into Sunday and towards Monday. But still, another batch of winds start building over Japan, a little tiny area to 190 knots, and offering what looks to be a better pattern, at least for a week out, and if not, much longer. And we think we know why this is going on, and I'm sure you will figure it out shortly here too. So let's take a look at surface level pressure and surface level winds, all right? So here is the gale that is developing in the Gulf of Alaska. Nothing huge, what is that, 35, maybe 40 knot winds over a tiny little area. But hey, since there's been really nothing going on lately, we'll take anything we can get. Another low developing here, just west of the dateline. So we go into Monday, the gale in the Gulf starts lifting north. The new gale pushes over the dateline and then starts building rather quickly as we get into Monday night with 45, almost 50 knot winds building over in the western and southwestern quadrant of this system. That's the main one. And then here we get into Tuesday. We have 55 knot winds solidly embedded in a broader area of 45 to 50 knot winds, all aimed well off to the east. And again, as we get into Tuesday night, still 50 knot winds. The gale literally stalls. It's not moving anywhere. So you just have this continuous fetch, just hammering the ocean surface there, imparting energy to the ocean. And that, of course, generates seas and swell. Then Wednesday, things start mellowing out a little bit. Another gale develops behind that on the dateline, though. Wednesday night, small area, not small, moderate area, 35, maybe 40 knot winds. But now it's interesting. Is the remains of the initial gale stealing energy from the secondary gale, or is it the other way around? Hard to say. Look at, they actually start rotating around each other as we get into Thursday night and Friday, but winds start fading out. Just a broad area of fetch. Certainly swell for Hawaii if the secondary system develops as forecast. Maybe not so much for California. Then we're into Friday night. Things sort of fall apart. Notice this tropical system here. If it develops, it supposedly is to recurve and start moving to the northeast. We'll see where that goes. And here we go. And then we get into Sunday night. Now, we're a week out now. 2 more gales develop. Another one over the eastern Aleutians with 35, almost 40 knot fetch. And another one off the Kuril Islands, these islands right here, pushing off to the east. And there we are at 180 hours. This is a significant upgrade compared to what we've been suffering through the past 2 to 3 months. We'll take it. Even if it's a tease, this is much, much better than where we were even last week. So let's go take a look at the effect of those winds on the ocean surface. So right now, tiny area. This is as of 18Z Sunday. Little area of 20-foot seas. Here we go. Here's where we are now. Was that 23-foot seas, 22-foot seas. So that's good for small, like 12, 13-second period swell pushing into California. Couple days out. Nothing huge, but hey, surf is surf. We'll take it. Then that system, and also into the Pacific Northwest, that system starts fading out. Here comes the main event, starting to organize as we get into Monday, and then boom, into Monday night. Tuesday morning, we have a nice area of 45-foot seas in the Gulf of Alaska, all fetched, aimed off to the east. Yes, sideband swell probably radiating to Hawaii, but the main focus would be anywhere from British Columbia down to, let's say, Point Conception, growing in area as we get into Tuesday, and still seas 43 feet Tuesday night over a good solid area. This is a fairly impressive-looking storm. Still 30, we'll get into, let's go Wednesday night, still 34, 35-foot seas, and then here comes the secondary system building behind. Now, this will be more focused on Hawaii. Still 30-foot seas into Thursday morning, 31-foot, and a small area 30-foot seas targeting Hawaii. I mean, look at this. It's just a whole bunch of, let's say, 25-foot or greater seas in play over the North Pacific Ocean. This is exactly what you want to see. That's days worth of swell if it plays out as expected. And then here comes new systems developing over in the West Pacific. We kind of go through a couple-day break here, and here we are into Sunday, and now we got at least 2 more. The one pushing over the dateline, 22-foot seas. Another one with 26-foot seas. Not as strong, not as impressive. We're at 180 hours out, but still, definite potential here with a consolidated jet stream flow. Where is the jet stream getting that energy? Well, we all know. We'll get into that in a minute. But certainly, we have turned the corner if the models are even halfway correct. Let's go take a look at wind swell potential. Now, we really don't care so much about wind swell, but we'll look anyway, and sort of gives us a hint of what the weather is going to be locally. So here we are Sunday. Yeah, there was some small wind swell in Northern California, maybe waist high or so, exposed breaks, driven by 15 to 20 knot winds off of the northern part here of North California. Nothing much. Relative to Hawaii, yeah, there's some easterly fetch here, but it's 600, 700, 800 miles away. Probably not doing anything for significant wind swell for the east shores of the Hawaiian Islands. We get into Monday, wind swell continues for California, but starts to fade. Notice low pressure building in the Gulf of Alaska. That pretty much means that high pressure is going to be fading over here in the eastern part of the Gulf. You can see a good close-in view of the storm in the Gulf. Most impressive, rather burly looking, and hard to believe it's really going to happen. No fetch. We're into Wednesday night. No fetch for California. No fetch for Hawaii in terms of wind swell production. And we're into Thursday. We're just looking local areas. Nothing. I mean, look at the whole Gulf of Alaska is 20, 25, 30 knot winds. A fair amount of activity. High pressure building in strong, though, on Friday. So let's go back here. Friday morning, you see high pressure kind of weak, but as we get into like late morning, all of a sudden, high pressure starts ridging into the Pacific Northwest. Winds start picking up along the California coast, 15, 20 knots. Also start getting easterly fetch here off. So high pressure, so low pressure, counterclockwise flow, high pressure, clockwise flow. That starts driving the north winds and the easterly trades coming towards Hawaii as we get into Friday night and into Saturday. Kind of looking like the beginning of a blowout for California. Easterly fetch and wind swell for the Hawaiian Islands, or at least trades for a little bit. We get into Saturday, or Saturday night, more of the same for California. Sunday, again, more of the same. A lot of wind in the forecast. We're out here. We're out 180 hours. Again, now look at this. High pressure filling the Gulf, kind of shutting things down. Trades into the Hawaiian Islands. Wind swell for California. We'll see. The jet needs to reinvigorate and push clearly into the Gulf of Alaska to cut off this high pressure in the wind machine. That's the one potential negative in all of this. All right, let's move on. Precipitation. Let's see if there's any potential. We're primarily looking here at California, looking for the potential of rain or snow, anything to help reduce fire danger in the Golden State. All right, but as you can see, high pressure in control as of Sunday evening, and we'll just sort of click through this. You can kind of already guess what's going on. Snow into the Pacific Northwest, but mainly up in the Whistler area, and we're into Wednesday. Still nothing, just high and dry in here. Here come the low pressure systems building in the Gulf. Does it make it to Northern California? Maybe, maybe a drib, some mist on the Oregon, North California border, but that's it as of Friday. And then high pressure starts building, blocking everything. Good precipitation into British Columbia. And maybe into Washington some, but nothing beyond that. We're looking out. Here we are. We're Sunday night, a week out. Oh, another little front trying to almost make it to Northern California, but that's a week out. Don't believe the models. So the short of it, high and dry for California for the next week. Pacific Northwest is the target, and primarily British Columbia. All right, so let's go take a look long term. Let's go see what's going on with the MJO. You know we like to talk about the MJO because the MJO really is what helps fuel the jet stream in the active phase and helps dictate the storm track. And clearly something is going on with the MJO. And then, of course, longer term, El Nino, La Nina, that's more like, for the next 6 months kind of thing. And we'll get into that right now. As usual, we like to look at winds across the equatorial Pacific, specifically in the West Pacific. So here's a chart. This is data from the TAO buoy array, series of buoys strung across the equator. There is the equator right there. This is the East Pacific here. This is the West Pacific here. That's New Guinea right there. The date line's right there. So, and then let's see, Ecuador in that area would be just off the chart here, somewhere in this area. Right, we're just looking at the arrows. The colors are water temperatures. We're not interested in that right now. But we see the arrows pretty strongly out of the east, southeast, strong trades over the eastern part of the equatorial Pacific, over the central Pacific, and blowing to the date line. Now, a little bit weaker today than they were yesterday, but still out of the east in what we call the Kelvin wave generation area. This area 5 degrees north and south of the equator from about the far west Pacific, 135 west to 170 west, about here, just the other side of the date line. And what happens is when you get westerly anomalies in here, that is, or just no wind at all, and that happens during the active phase of the MJO, and the MJO is, of course, that periodic weather pattern. It goes on and off from active to inactive, and it traverses when in the active state. It takes about 3 or 4 weeks to go the whole way across the Pacific. Once the active phase goes across the Pacific, the inactive phase comes behind, and it takes 3 to 4 weeks to go across the Pacific. And actually, the two of these, they traverse the whole planet on the equator, going from west to east. All right, so we're looking for signs of the active phase of the MJO, and typically what the active phase of the MJO does is suppress trade winds here in the West Pacific, and when that happens, that helps in part, well, you get precipitation, evaporation, precipitation, moisture here in the West Pacific, that imparts energy to the jet stream. It pulls the jet stream together, it consolidates it, and then that's what helps helps feed the storm track across the North Pacific. And that's exactly what's happening right now. So we see trades, they look like they're a little bit suppressed here in the West Pacific, but let's look at anomalies, differences from normal for this time of year. You see these big arrows here suggesting strong easterly winds, but these arrows here indicate, well, how much different are they than they normal for this time of year? And what we're seeing is not really that much. The whole way across the Pacific, no. And even over here in the Kelvin wave generation area, pretty much a normal pattern. So neither the active or the inactive phase of the MJO is showing up in this chart. But remember, this is a 5-day mean. So it sort of is a lagging indicator. The winds can change over here, and it takes literally 4 or 5 days later before it'll show up on this chart. So let's go take a look at the forecast, and that'll give us a little bit better clue of what's happening. So here we go. This is a little bit of an odd chart. It's the 850 millibar zonal wind anomalies, which is fancy words for just, are the winds blowing harder out of the east or harder out of the west than normal? This is the whole globe on one chart. But if you see yellows or reds, like specifically there, that means winds blowing out of the west, and that's exactly what we want. We don't want the blues. Blues are blowing out of the east. So the reds, one can assume to be the active phase of the MJO if it's in the right place. So the Pacific Ocean, okay, well, there's the date line, 180 there. Pacific Ocean starts about 135 east right here and goes to about 80 west over here. But the Kelvin wave generation area, that area in the West Pacific, that's what we're really interested in, from here to about here. And you just go draw a line the whole way up the chart in your mind. All right, so we see reds in that area, and that started about November 1st. Looks like the active phase of the MJO, strong westerly anomalies, but with easterly anomalies just on the east side of the Kelvin wave generation area. But that's all faded. Here's where we are today. West anomalies, pretty solid in the Kelvin wave generation area. That certainly explains why the jet stream has all of a sudden woken up, and all of a sudden the models are just saying, hey, we're going to have some storms on the chart. All right, but how long is it going to last? Well, we can kind of look here and go, maybe not as long as we'd like. We see westerly anomalies holding till about November 15th, and then they start moving out of the Kelvin wave generation area. We see strong easterly anomalies. This is over in the Indian Ocean, but they're supposed to start encroaching into the West Pacific about the 17th of November. Not so good, but at least we do have a little window. It looks like it's right around in here. Let's dig deeper. So here's another component of the MJO. Remember we talked about there's the east-west wind component. There's also the precipitation component. And this is a prediction of outgoing long-wave radiation, OLR. Fancy word for cloud cover, okay? If you have blues, those are negative anomalies. That means less sunlight bouncing off, less outgoing long-wave radiation bouncing off the ocean surface. That means clouds, and one can assume that means the active phase of the MJO. The inactive phase is this, the reds. That means more sunlight bouncing off the ocean surface without clouds in the way, right? So, all right. So we have the active phase of the MJO in the West Pacific, the inactive phase building, per the statistic model, in the Indian Ocean. Active phase slowly easing through the Kelvin wave generation area. So Kelvin wave generation area, again, goes from, so there's, the equator is right along there. There's South America, right? There's the Philippines, New Guinea. Kelvin wave generation area, 5 degrees north and south of the equator, basically right in there, right in that area. So you see the active phase of the MJO starting to move quickly east and out of the Kelvin wave generation area 10 days out, and then holding it somewhere out there through day 15, while the inactive phase of the MJO, the jet stream suppressing component of the MJO, starting to work its way into the West Pacific. Now, the dynamic model says pretty much the same thing. In fact, let's go look at the last frame here. Yes, the active phase, the MJO on the dateline, even weaker on the dateline at day 15. So pretty much the two models are in sync. So here's another prediction, and you can use this to measure the strength of the MJO. Instead of qualitative terms, this is more quantitative. So how do you read these charts? These are called phase diagram charts. Basically, this circle here, assume you're looking down on the North Pole, and the equator is like out around here. The MJO travels from west to east over the Indian Ocean, from the Indian Ocean over the Maritime Continent, across the West Pacific, over under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. The heavy dot is where the active phase is, so it's in the West Pacific today. The further away from the circle it is, the stronger it is. So if it was way out here, it'd be very strong. So say a modest, just a modest active phase of the MJO in the West Pacific today, per the statistic model, and forecast to get weaker 15 days out and move over North Africa. The dynamic model says basically the same thing, but the active phase moving east even quicker and falling back into the Indian Ocean 15 days out. Here's the upper level model. So it's at about 200 millibar level, up at the jet stream level. The greens are areas favorable for precipitation. The oranges areas not favorable for precipitation, so one can interpret this as the inactive phase, and this is the active phase. This suggests the active phase racing east and moving out of the Pacific by about November 25th. Now, this is at the upper levels. It actually takes longer down at the surface, like lags 5 days behind, so let's say November 30th. Anyway, the inactive phase starts building into the far West Pacific on November 25th, and it makes its way across the Pacific, pushing in through Central America around December 10th. And then here comes another pretty strong active phase of the MJO starting about December 10th and working its way to the mid-Pacific, just 5 days before Christmas. So we have a window right now. Then things are going to shut down for a while, and then the window opens up again, let's say, maybe the 10th of December, and goes the whole way through at least Christmas. So here's the 1 month MJO forecast. It goes out a month, and again, it's one of these charts that has the whole planet on one chart. There's the date line right there. Kelvin wave generation area between this tick mark over to about here, so go straight up through there. And one can clearly see, the dotted contour is the inactive phase of the MJO. The solid contour is the active phase. You can actually go back in time and see active phase, inactive phase. Where are we today? Here we are, November 9th. Active phase building into the Kelvin wave generation area. The oranges and the reds are westerly anomalies, so that's supposed to continue through till about, probably somewhere around just before Thanksgiving, maybe the 20th of November or so. Then here's the inactive phase. It's supposed to make a little foray into the West Pacific, but then sort of backtrack and fall apart, with westerly anomalies more or less holding in the core of the Kelvin wave generation area the whole way through the end of this model, so that'd be December 7th. So that's not so bad. We got to keep our eyes. Now notice this very strong easterly anomalies that have been just locked over in the Indian Ocean since the end of summer and non-stop. At some point they have to break down or go on the move, but for right now, fortunately, they're supposed to primarily be locked in the Indian Ocean. And then here's the 3-month run of the CFS model. So this is a little bit different. Again, whole planet on one chart, date line running right up the middle, but the forecast is going to the top, past performance is on the bottom here. So here's where we are right now, November 10th, Kelvin wave generation area from here to about here. Okay, we see westerly anomalies in the Kelvin wave generation area, and for the most part, just looking up, they're supposed to hold nonstop into, almost the end of January, or maybe even beyond that. Let's overlay the MJO. Here you go. Here's your active phase of the MJO, the solid contour. It's supposed to hold in the Kelvin wave generation area till, about November 21st, get eyeballing it. Then the inactive phase sets up, but even westerly anomalies forecast to continue, even though the inactive phase is in control till maybe, December 10th or so. Then the active phase again, from there into right around Christmas time, followed by the inactive phase into early January, and you kind of get active, inactive. You see the pattern setting up. This is actually kind of a normal thing when you have El Nino in control, the active phase kind of fades and everything just turns into a giant active phase. When you're in La Nina, the inactive phase sort of takes over. You still have the active phase, but the inactive phase sort of takes precedent, is more dominant than the inactive phases, and the active phases are weaker and less noticeable. Okay, interesting. So then, on top of all that, let's overlay the low-pass filter. All right, so this solid contour is centered right on the date line, as it has been for a year, 2 years now, something like that. Okay, 2 contour lines. So this is like a low-pressure bias on the date line, and if it gets strong enough, you can say, well, that's a sign of El Nino, and we've been watching this for a couple of months now. The models have been projecting this. At times, I mean, literally from day to day, it will show a third contour line developing somewhere here in the December, early January timeframe. One would go, God, that almost looks like an El Nino pattern, but there's nothing else other than this one chart that's suggesting something smelling like El Nino. The other thing here is the dotted contour is like a high-pressure bias. It's locked in the Indian Ocean, and that too looks like El Nino, but this is the only chart that's suggesting anything like remotely like El Nino, and actual water temperatures in the ocean are not at all like El Nino. So this is sort of a red herring, but it gives us a little bit of hope in the Pacific Ocean. We'll take whatever we can get. All right, so enough about the MJO. Let's start looking longer term at El Nino, or if we can see some signs of what's going on El Nino-wise in the ocean. And that El Nino in the ocean is characterized by warm water, normally in the West Pacific, moving off to the east. So this is data from the TAO buoy array. Again, that series of buoys strung across the equator used for monitoring El Nino. These are the anchor lines on the buoys, strung the whole way, was at 3,000 miles across the Pacific Ocean. And there are actually, the little X's are sensors on those anchor lines used to detect temperature. So we can get a profile of what subsurface ocean temperatures look like, and then use a model to sort of fill in the gaps, and you get this profile that shows, and this is all in centigrade, 30-degree centigrade water in the far West Pacific, reaching to, so it was actually at one point, I think it was over to 180. It's actually backtracking. Over time, you can sort of see this. It's back to, what is that, about 173 east today. The 29-degree isotherm is at about 173 west. I think that's backtracked a little bit too. The 28-degree isotherm at 160, it was over at 153 a couple of weeks ago, so it's backtracking too. The 24-degree isotherm, though, is locked solid at 105 west. So what's this all mean? Well, there was a push of warm water, we think, like a Kelvin wave, driven by westerly winds in the Kelvin wave generation area, driven by the active phase of the MJO, but it appears to be retreating, and these isotherms are sliding back to the west. So that's not necessarily great news. Now here we go, but this really tells the picture. Anomalies, differences from normal for this time of year. All right, so what do we see? You can just see it plain as day. Warm water, plus 2-degree anomalies in the West Pacific, plus 2-degree anomalies in the East Pacific, and one pocket to 3 degrees. This is actually a Kelvin wave, a weak one, but a Kelvin wave number 5, pushing into the far East Pacific today, and then you see there's sort of a gap in between. This almost looks like another Kelvin wave trying to organize, but there just isn't enough momentum. There hasn't been strong enough westerly winds or anything, but still, there's nothing here that even remotely suggests La Nina. Otherwise, you'd see cool anomalies here, cool temperatures here, but no, we see warmer than normal. So that's kind of a good thing. Here is our, what was sort of a hint of a cool pocket, and it is getting steadily weaker and backtracking, moving back, sort of backwards, not to the east. So that is even giving us more hope that at least we're neutral biased warm, certainly not moving to cold at this moment in time. Another way to confirm this is the sea height anomaly data. That is a satellite strip out all it's used for measuring. We can use it to measure actually swell heights and sea heights in storms. But if you strip out all the wave heights, you strip out the wind waves, you strip out even the tide, and what we're looking for is a bump on the ocean surface on the equator. That's all we care about is the equator. You see basically pretty much a neutral pattern. Here's the date line right there. Here's the equator. That's South America. That's New Guinea there, Australia, you get it. Okay, over here in the far west Pacific, and you're only interested in 5 degrees north and south of the equator. You see basically just a neutral pattern, if anything. You see one pocket of positive anomalies, 5 centimeters above normal here. And so if you have warm water at depth, it expands, and that's what pushes that bump on the ocean surface, like right here that we're talking about. Okay, so that all this means is, yeah, there's some warm water under the equator. We think it's moving off to the east. And the other good news here is there was a bunch of negative anomalies in here off of Peru past couple of months. And it was really looking like La Nina was starting to develop. It's all just gone now. We're back to pretty much neutral anomalies along Peru. And so, in all, yeah, there's some warming according to this, but nothing significant. It's basically ENSO neutral. Oh, we skipped this chart before. So this is the same deal. Data from the TAO buoy array, just a different model connecting it. And it, too, showing the warm anomalies in the West Pacific, moving the whole way to the East Pacific. And now, here's this last little holdout here. We've been watching this cool pocket. It's been upwelling steadily forever off of Peru and Ecuador. It's almost gone now. You see this Kelvin wave. It's actually pushing off to the east. In fact, well, let's look at another chart right now. This is upper ocean heat anomalies, basically surface temperatures in the upper 300 meters of the ocean, the whole way from the West Pacific to the East Pacific over time. So this is, and the oranges and the reds, those are warm anomalies. So that this is effectively a Kelvin wave. This is back a year ago. So November last year, Kelvin wave probably number 3. That made its way into the the Ecuadorian coast. Then Kelvin wave number 4 in January, started by the active phase of the MJO, westerly anomalies. You can see it, warm water building, and it took 3-4 months till April to reach Ecuador. And then 2 other mini little Kelvin waves over the summer, but they went nowhere. They just sat here. Notice we had this perpetual sort of cool pocket off of Peru and Ecuador. And then here is Kelvin wave number 5, started in probably late August from the active phase, the MJO there, building west winds, taking warm anomalies, pushing them off. But there's not a whole lot of warm water left over here in the far West Pacific Ocean. And then it, too, is making its way across the Pacific, and so Ecuador's right about 80, so we're, 10 degrees on the equator, so that's 600 nautical miles from this Kelvin wave pushing into Ecuador. So maybe in the next couple of weeks it'll make its way there. But nothing, it's not nearly as strong as these other, or as large as these other 2 Kelvin waves. This is a very weak Kelvin wave. If you have multiple Kelvin waves and they're strong enough, they can kick off El Nino, but we don't think that's going to happen because we were sort of like in a weak El Nino pattern last winter. There's no way you're going to bridge the gap and get 2 years of that. So likely this is just holding things neutral, kind of normal, if you will. Nothing greater, nothing less. But that's okay. Normal's better than nothing at all. All right, so let's go take a look at ocean surface temperatures, right? Because that's really what matters. You have to have warm water on the ocean surface to get evaporation, and evaporation then imparts energy up into the atmosphere, and if it goes high enough, it feeds the jet stream, and then that kicks off the storm track. You know the drill. All right, so what we're interested in here is Peru, here's Ecuador. We see weak cool anomalies off of Peru. We also see a little bit of warming down here. I mean, we know there's a Kelvin wave under this area right here, not on the surface, down below, and it's eventually going to work its way. We think it's, where'd we say, 90? The leading edge of it is like right here, just off the coast. It's eventually going to push into here and start upwelling to the surface and make some degree of a warm slick around here, and that in turn, hopefully, if it lasts long enough, it feeds the jet stream. But you really got to have warm anomalies here for like 3 months, and what we've really had is cool anomalies in this area for the past 3 months. So the jet stream is like predisposed and to not be pushing very strong into the eastern Pacific. Notice there's like cool anomalies the whole way out to 120 west. That's California. So it's no surprise that there is high pressure off the California coast because the ocean down south of there has been cooler than normal pretty much all summer. And even though we have a Kelvin wave getting ready to arrive, and even though it might erupt to the surface and create warming here, that warming would have to hold for 3 months. And by the time that happens, we're talking, you're into late March or April, and by then your winter surf season's already over. So we guess that the predisposition is towards sort of high pressure off the California coast this winter. Anyway, so we have some warming. I mean, you can see some warming coming to the surface from the Galapagos west of there, and much stronger further out. We think that the balance of storm production this year is mainly going to be like in the western Gulf dateline area, not so much pushing into the California coast, which sort of does not bode well for precipitation in California this winter as well either. Here's the ocean temperature trend for the past 7 days, right? You see gentle warming along Peru. We're only really interested on the equator here, not way off in the outer reaches. Little pocket of cooling here, the last of the cool water at depth, probably pushing up to the surface here off of Ecuador. And then gentle light warming here west on the equator from the Galapagos, but no wholesale warming or cooling anywhere in the equatorial Pacific. And then finally, here is the actual sea surface temperature anomalies for November 9th. And what do we have? You see cool water, as we talked about, south of California, south of the equator, but, over a pretty good area. North of the equator, you have warming, but not super warm. So they sort of cancel each other out and goes, just kind of a normal pattern. And the normal pattern is high pressure off of California this time of year. Now you see there is a little bit broader area of warming here. Again, really only 5 degrees north and south of the equator. Once you get, further off here to the west. So there's two, let's do it this way. There's the two official, well, there's 4 actually, but we'll just say there's 2 main areas for measuring water temperatures. The Nino 1.2 region, which is right around in here off of Peru and Ecuador, and the Nino 3.4 region, which is the official El Nino monitor region from 120 west, 5 degrees north and south of the equator, out to 170 west, so a box right there. If you just eyeball that, you go, yeah, temperatures are warmer than normal, but they're not cooking. If you were in El Nino, you'd want to see a big old like a triangle of red over this whole area. We're not seeing anything close to that. This is just barely above dead neutral here, and in the Nino 1.2 region below normal. In fact, let's go look at the actual temperature trend. So here's the data for the Nino 1.2 area. Okay, this is normal right here. Our value today is 0.915, so almost 1 degree below normal, and you can just eyeball this and see the temperature has been below normal pretty much. This is late summer, all fall in the Nino 1.2 region. So this is the area tucked up there by Peru. And that explains why we have high pressure kind of locked down over the eastern Gulf of Alaska. And then here is the official El Nino monitoring region, the Nino 3.4 region. Here's the dot, 0.220, 0.2 of a degree above zero. That's effectively neutral. And if you actually look, we were below normal the whole way through late summer into fall, and we only got neutral starting October 1st. So for a month, 5 weeks now, we've got another 2 months to go before this would have any effect on high pressure off of California. Or significant impact on the jet stream. Basically, all this is saying is, yeah, we're kind of like normal. Yeah, we're a little bit cooler at one point, a little bit warmer today, but no strong push like either towards El Nino if it was warmer, or La Nina if the temperatures were cooler than normal. So let's go take a look at the atmosphere. We're looking for, we've looked at the ocean and going, are we in El Nino or La Nina? The ocean says, probably neither. We're just dead neutral. Let's look at the atmosphere, see if it has any sense of where we're going. So this is the SOI, Southern Oscillation Index. It's the difference in pressure between Darwin, Australia, and Tahiti. When the index is negative, For a day, it doesn't mean anything. For 3 or 4 days, it doesn't mean anything. For 15 days, then that would be a sign of the active phase of the MJO. For 80 80 or 90 days, then that would be a sign of El Nino. All right, so today's contribution, minus 14.64. You can kind of look back here. Hey, we've had a couple of good little negative readings, and it's been going on for about 15, 17 days. I think we're moving towards the active phase of the MJO, and of course, that's what all the other models are saying, so that doesn't take a genius to figure that out. 30-day average, yeah, so we're at minus 4.71. What were we at the beginning? A month ago, we were at minus 9.93. So, yeah, maybe we're moving towards the active phase of the MJO, but it's not a very strong active phase of the MJO. And then the 90-day average is minus 8.51. This will tell us whether we're El Nino or La Nina. Where were we a month ago? Minus 6.86. So are we moving towards El Nino? No, because we weren't at El Nino a month ago. We're weakly biased towards El Nino, but no clear indicators at all that we're going in that direction. We're just kind of muddling along. We'll say weakly biased towards El Nino, but the operative word here is weakly biased. I mean, just barely. So finally, what is the forecast, at least in terms of sea surface temperatures? And this is a CFS model, but it's a pretty good representation. There's like 15 different El Nino, La Nina models, and this is pretty consistent with what all of them are saying. So back this summer, back last winter, remember we said we were in a weak El Nino. This said temperatures were about sea surface temperatures were about 3/4 of a degree above normal in the official El Nino monitoring region. Then this summer, remember we had that cold snap and things sort of drop below normal. Now here we are, early November. Temperatures, according to this, are supposed to be 1/2 degree above normal, 0.5. We really know we're more like down here at about 0.2, so this model's overhyping it a little bit. And the forecast is for us to basically meander around about 0.2 to 0.3 degrees above normal, so 1/4 of a degree above normal, but stay there the whole way into July. So basically, weakly biased warm in the official El Nino monitoring region. We talked about this last week and the week before, this long-running PDO, Pacific Decadal Oscillation. That's like a 15 to 30-year cycle where sometimes the Pacific sort of acts like it's in a weak El Nino for 15 to 20 to 30 years at a time. We think we crossed the threshold into that pattern back with the El Nino that started in 2014, and we're still there. So, and then these temperatures, this forecast suggests, well, we're kind of going to stay biased warm. Yeah, maybe this winter won't be great. We're not in El Nino. We're certainly not in La Nina. We're just neutral biased warm. That's not a bad place to be. And it looks like we're going to hang that way for a while, maybe the whole way through next summer. All right, so what does all this mean? Well, for right now, we're in the active phase of the MJO, and that, of course, feeds the jet stream, and that's clearly obvious with the models all of a sudden waking up out of their slumber and going, hey, fall's here, we're going to have some surf. And you can see there's one little gale off the coast of California right now, a much stronger one forecast for the northwestern Gulf of Alaska in a day or two, and then a whole series of other lesser gales behind that. The models are always a little bit unstable, so we're not exactly sure how it's going to play out. The active phase of the MJO is supposed to run till almost about Thanksgiving, so I'd say there's a good window opportunity here for storm development and for swell development. Make the most of it while you can. Then, after Thanksgiving, the bottom falls out for a little bit, and then it's supposed to wake up again come, maybe a little bit before Christmas, and run for a while after that. So, not a horrible situation surf-wise, finally. Snow-wise, rain-wise in California, not looking so good. Suspect high pressure, stubborn high pressure is going to be in control for a bit longer. At some point, it'll get pushed out, and we will get precipitation. But are we going to have above average rainfall for the season? Probably not. Are we going to have, just normal? Maybe not. Too early to know. Really, the way the trend has been the past couple of years, the rain season really doesn't get going till later in December. So too early to guess. We'll see. But if anything, I'd say we're kind of biased towards a La Nina pattern in the East Pacific right now. Anyway, and then long term beyond that, hey, we're not moving towards La Nina. None of the models are saying it, so that's a good thing. All right, so if you enjoyed this video, be sure to click the like button, subscribe. There's a little option down below here. You can just click the button, put in your email address, and you'll get notifications when we update these forecasts. And other than that, we'll be doing it again. We think next week. There's maybe a possibility. We'll see how things go. But either way, for sure the week after that. So thanks for watching, and we'll see you again next time we do this. Thanks.